Hello, 7th grade, and welcome to Lesson 8-3 on slope and Y-intercept. In tonight's lesson, we have two objectives. First, you will be able to find the slope of a line, and secondly, you will be able to use slope-intercept form to graph a linear equation. So we're going to go ahead and get started by talking about slope. And the first way to talk about slope is, well, figuring out what it means. Slope is a ratio that describes the tilt of a line, meaning how much it goes up or down. So above I have these two pictures, this one and this one. And looking at it, I could ask you the question, which one has a higher slope or bigger tilt? And looking at this, I wouldn't be surprised if all of you chose this one. Because if you look up or look at it, you have to go a wide range to keep going on that road. Your slope changes very, very quickly. Well, on this one, this first one, it seems like just a straight road. So again, the slope is just the tilt of a line. And the first way we're going to talk about slope is this: vertical change over horizontal change. All right, or rise divided by the run. All right, and again, ratio just is another way to compare. So we're comparing how much it goes above to how much it goes across. So find the slope of each line. And I have here on this example, it's kind of hard to see, but at each one of these, there's a red little dot. All right, because these are all points on the line. Now, to find the slope of it, or the tilt of the line, you can choose any two of these points that go through the coordinate plane. So here, I'm going to choose this one and this one. All right, so I highlighted them in green. And what I have to see is how many do I have to go either up or down to get to the next point. I always start with the point closest to the left. So here. Now I have to go, it looks like, up 1 in order to get this point. So my rise is 1. And then I count how many I have to go over. Well, that's 1, 2. So my run is 2. So my slope here is 1/2. Let's try another example. All right, here we have A. All right, and again, I'm going to start with the point closest to the left, which is right there, and then B, which is right there. Now this time, to get to the other one, I still do rise over run. Again, rise just means how much you go up or down. You can think of the sun either going up or setting, rising or setting. All right, and then run is just, well, you run across the road, you're going vertically, or excuse me, horizontally. So here, to go from A to B, I have to go down 1, 2, 3. Now because I go down 3, it's going to be a negative. So my rise here is a -3. And then, well, I have to check how many I go over. And that is 1, 2. So my slope here is -3/2. All right, now it's your turn. I would like you to do B. And when you're all done, come back and check your answer. So go ahead and pause me now. All right, let's check this one. Well, looking at it, from point B to A, I go up 1, 2, 3. So my rise is 3. And I go over this way, 1, 2, 3, 4, 5, 6. I get a slope of 3, 6. But of course, we've learned how to simplify. So really, through 6, my slope turns into 1/2. There we go. So that's, oh, and then I have C and D, which are a little bit different because they're still talking about the slope of a line, but instead of having a tilted one, I have a horizontal and a vertical line. But it works the same way. What I do is just measure, well, rise over run. That's what I look at. All right, and here, well, to go from this point to this point, do I have to go up or down any? No. So it'd be 0, and then I count how many I go over. 1, 2, 3, 4. I get 0 over 4. And if you put that in your calculator, 0 divided by 4, you find out the slope is 0. All right, same with this one now. I'm looking at rise. Well, to go from one point to the other, I'm going to start up here. I'll go 1, 2, 3, 4, 5, 6, 7. All right, so I went down 7. And then, well, to run over, well, I didn't have to go anywhere. They were down. It was a vertical line. So I get -7 over 0. Now, if you put that in your calculator, which you could certainly do, -7 divided by 0, you'll get an error, or they'll tell you it's undefined. Now, and that works that way because anytime you try to divide by 0, it's never going to work. You can't have 0 in the denominator. It just isn't possible. And there's a whole spiel on that, but I'm not going to get into that one tonight. So again, if you have a horizontal line like C, you're going to get a slope of 0. But if you get a vertical line, you're going to get an undefined slope. And you just write that, undefined. If they ask you what the slope is, you just automatically write undefined if it's like that one. So here's a quick little summary just for you to know. All right, so if your slope is going upwards, like this, it's going to be a positive slope. So your answer will be positive. But if you have a slope that goes down, it means as one increases, the other decreases. So the slope is going to be negative. And it's just as I said with that last example, if it goes up and down like this, it's undefined. But if it goes across horizontally, it is 0. All right, so those are just some quick things to keep in mind when you're doing these problems. So now we're actually going to find the slope using coordinates. Sometimes they don't give you a graph, all right? And they say, well, find the slope if I tell you these 2 coordinates. You do, well, you have to go through a little more work on these ones, all right? And what you have to do is you find the difference in the y coordinates and then divide it by the difference in x coordinates. Some way that you might hear it said is y sub 2 minus y sub 1 divided by x sub 2 minus x sub 1. All right, and I'll show you how that works with this next example. So here, it's, as I said, y sub 2 minus y sub 1 over x sub 2 minus x sub 1. All right, here we have our coordinates. We have 7, 5, and then the coordinate negative 2, 0. Well, this is x, and this is y, and this is x, and this is y. But we could go a step further and say, well, this is my first x coordinate, this is my first y coordinate, this is my second x coordinate, and this is my second y coordinate. And then what we do is put it in that equation. Well, y sub 2 is 0, minus y sub 1, which is 5, over x sub 2, which is negative 2, minus x sub 1, which is 7. And then I simplify it. Well, 0 minus 5 is negative 5. Negative 2 minus 7 is negative 9. Now here I have negative 5 over negative 9. If both of them are negative, it turns into a positive 5 ninths. So my slope here is 5 ninths. And again, the only reason it changed to positive is this negative sign in both the front and above. Because remember, if you multiply or divide both the numerator and denominator, or 2 numbers by a negative number, it turns your answer positive. So again, we'll do B together, just for a little extra practice, and you're left to do C. So y sub 2, again, I could label them first, x sub 1, y sub 1, x sub 2, y sub 2. And the first coordinate is the sub 1, the second coordinate is B, in this case, is sub 2. And I simplify. Well, y sub 2 is negative 3 minus y sub 1, which is negative 3, over x sub 2, which is 4, minus, well, a negative 2. All right, and something to keep in mind here is, well, 2 minus signs in a row turns into a big positive. So that might help. Negative 3 plus 3 is 0. 4 plus 2 is 6. So I have 0 over 6, which is the same thing as 0. All right, I want you to do C now. Go ahead, do it the same manner, and when you're all done, come back and check your answer. So go ahead and pause me now. All right, let's check those answers, shall we? So we should have 3 minus a negative 1 divided by negative 2 minus a negative 2. And if we simplify this, again, 2 negatives in a row make a positive. I get 4 over, I have opposites here. Negative 2 plus 2 is 0. Now this is going back to that one. We can't have 0 in the denominator. So in this case, our slope is undefined. There we go. All right, so now we have a real world situation of it. All right, so what we're going to have to do is start with this example. A store sells elements in bulk for $6 per pound. Graph the relation pounds of elements versus the cost. Find the slope of the line through the points on your graph and compare the slope to the ratio. Well, I started us off by making this graph. And I just have one quadrant on my graph because I'm not going to be able to sell negative amounts or negative pounds of elements. It wouldn't make sense. I can sell 0 pounds, but I can sell a positive infinity. So I can only have positive numbers in this case. So that's why it's just this one part. So I labeled it with the number of the pounds of elements on the bottom and the cost along the side, and I go ahead and put it in. Well, if I have if I sell 0 pounds of elements, I get $0. If I sell 1 pound, I get $6. 2 pounds is 12, 3 is 18, and 4 is 24. Now I know this because it tells me it's $6 per pound. So I just times the number of pounds by 6. And I can connect those dots, oops, and go like that. Now in this case, I didn't go by ones, I went by sixes. So it would not be a good idea to try to do rise over run, because that would make it a lot more difficult than what it needs to be. So in this case, what I'm going to do is use 2 of the points on my graph and find a difference in them, just like we were doing in these last examples. So I'm going to make it easy, and I'm going to choose this point. So I'm choosing point 0, 0. And I'm going to choose, why not, 4, 24. All right, so again, looking at this, I know this is x sub 1, this other 0 is y sub 1, this other coordinate, my second one, x sub 2, y sub 2. And I do the same thing, y sub 2 minus y sub 1 divided by x sub 2 minus, well, yeah, x sub 1. So I start with that, 24 minus 0. Again, I got that from y sub 2 and y sub 1, divided by x sub 2, which is 4, minus x sub 1, which is 0. And I go ahead and subtract that, 24 over 4, which is 6. So my slope here is actually 6. Now I'm going to just show you one thing, just so you know. You don't have to be concerned with what points you choose on the graph, because your slope should turn out the same way. So I'm going to do this problem again with 2 different points. I'm going to choose this one right here, so 1, 6. And I'm going to choose this one right here, so the 3, 18. And I could do the same thing. Y sub 2 is 18 minus 6 over 3 minus 1. All right? And then I subtract them. 12, and then 3 minus 1 is 2. And I get 6. There we go. So you can see how I got the same slope, no matter what points, 2 points I chose on my coordinate plane. All right? Or on my slope, I should say. So don't be concerned about what 2 points you pick, just as long as you pick 2 good points for you. Now we're going to use slope to graph linear equations. So we're going to use slope-intercept form. So we know how to find the slope now. We did it in 2 ways. We just did rise over run, or we can find the change in the coordinates. But now we're going to use something called the Y-intercept, which is this, the point that crosses the y-axis. All right, so we use the slope, that rise over run, and the y-intercept to do slope-intercept form, which is this. Y equals m times x plus b. Now, just so you know, m in this case is the slope. So whatever we were talking about, that rise over run, that 6 we just found in that element example, those were all slopes. So whatever we find for the slope, we put in for m. And then b, well again, that point that crosses the y-axis. So whatever point crosses the y-axis, that's what you put in for b. So I have this example down here, which I'm going to make a little bit bigger for us to see. We're going to go ahead and do this. The first thing we are going to find is the slope. All right, and because I already have it graphed out, I'm going to just do rise over run by picking 2 points. I'm going to pick this one, and why not that one? All right, and then I go from left to right on my rise. 1, 2, 3. So I have to go up 3, so it's a positive 3. Then I go over 1, 2, 3. I go over 3. So my slope here is 3 over 3, or just 1. All right, so I found my slope. Now I have to look at my y-axis, or that b. And again, that is wherever it crosses on this y-axis, so this y line. So when we take a look at what number does it cross? Well, it crosses right here at 3. So my y-axis here, my y-intercept, I should say, is 3. So I have my 2 pieces of information. Now I put it in there. y is equal to, well, my slope, or m, which is 1, x, plus, and b is 3. There you go. And this could actually be simplified even more. 1x is just the same as just x, plus 3. That is slope-intercept form. Let's try it again. So, oh, this time we get to graph them. So we have 2x plus 3. When you graph them, what you start with is, again, this y-intercept. So whatever the y-intercept is, that's what you put down first. And here it's 3. So on my y-axis, I find 3. Now I look at my slope, which is 2. Well, when we talked about slope before, it's always rise over run. So I have to figure out, well, what number can I put on the bottom that would keep it 2, but would turn it into a fraction, so I know how many I have to go over. And in this case, you always put it over 1. So if you have a whole number with the slope, you just put it over 1. And then we go ahead and graph it. So I go up 2 over 1, up 2 over 1, up 2 over 1. Now, that's what we do on that side. But I know my graph is going to continue going this way. I just have to figure out how to make those points. Now, to go to the positive side, we did exactly what we said, up 2 over 1. But now we have to do the opposite to keep going with my line. So instead of going up 2, I go down 2 over 1 in the other direction. Down 2 over 1. Down 2 over 1. Down 2 over 1, and so on. Until you have a whole bunch of points. And excuse my line, it's not the straightest, but that's what it would look like. All right, so here, let's do B together again for one more practice. Again, we start with the y-intercept, so that number just being added or subtracted, which is 4. Then I need to do my slope, and this time, they don't even give me a number. They just say negative x. But if you keep in mind, there is always a number in front of it. They just don't show it because they don't think it's necessary. So what number can you multiply by, but it keeps that answer the same? Well, that would be 1. So in this case, because it's a negative, we have a slope of negative 1 over, and again, you'll always put it over 1. It's a whole number. So there we go. So in this case, I start at 4, and I'm going rising with negative 1. So I'm going down 1 over 1, down 1 over 1, down 1 over 1, and so on. Down 1 over 1, and I'll get a whole bunch of points. Now to go in the opposite direction, so before the y-axis, I do the opposite again. Up 1, over 1 in the other direction. And you just keep on doing that, and you get a graph that looks like that. And again, last step, connect the dots, and put arrows at the end because your line continues on. It goes on forever. All right, so now we have these two. Graph each equation, 1/4 x minus 2. All right, and again, I guess I'm going to show you this one. Here, we start at negative 2. So I put that down. Now this time, my slope, they already have it as a fraction. And in some ways, that makes it easier, because I know my slope is 1/4. So I go up 1 over 4. So up 1 over 4. Up 1 over 4. Well, that's as far as I can go on that graph. So now I do the opposite on the other side of the y-axis. Down 1 over 4 in the other direction. Down 1 over 4 in the other direction. And connect the dots. There we go. Now I want you to try to do B here. We have y is equal to negative 3 times x. So here they give you the slope. But they don't have a y-axis. So what do you suppose a y-axis is going to be in that situation? Well, if they don't show it in this case, what number are they adding or subtracting? Well, it can't be 1 this time because they have to show that. You can only multiply by 1. That's the identity property. But you can add 0 and keep it the same. So I gave you that. Now I want you to graph B. So go ahead and do that. And when you're all done, come back and check your answer. So pause me now. All right, let's check it, shall we? Well, I start at the origin, or 0. And then my slope here is actually negative 3 over 1, since it's a whole number. So here I have to go down 3 over 1. Down 3 over 1. Down 3 over 1. On the opposite side, I go up 3 over 1. Up 3 over 1. Up 3 over 1. And connect those dots. And this brings us back to that little page before that I had all those things on. If it's a positive slope, it looks like that. If it's negative slope, it looks like that, and so on. So, because I saw this as -3, my slope should be going down. But here, with my slope of 1,4, it's going up. So it's another quick little check if you want to check them to make sure your graph is going the right way. So if you took this one, but your graph is going up like this, you know automatically it's wrong because it's a negative slope. So it should be pointing downwards. All right, and final problem for the night, and then you are all done. A ramp slopes from a warehouse door down to the street. The function y is equal to -1/5 x plus 4 models a ramp, where x is a horizontal distance in feet from the bottom of the door and y is a height. Graph this equation. So again, I want you to do this one. I want you to graph that, and when you are all done, come back and check your final answer for the night, and you get to take a break and relax. So go ahead one last time and pause. All right, let's see how you did. Well, I'll start with the y-intercept. What the number being added is 4. And then my slope here is -1/5. All right, so what I like to do for this, they show it like this. For my slope, I like to assign this negative sign to the numerator. So I think of it as -1 over +5. Because again, only one of those numbers is negative. If you make both negative, it turns out to be a positive slope. So now I do -1 over 5. Down 1 over 5. Opposite on the other side. Up 1 over 5 the other direction. Up 1 over 5 in the other direction. And that is what my line looks like. And again, arrows at the end. All right. That was your lesson for tonight. Tonight we talked about how to find the slope using either rise and run, or if you have two coordinates like this, you find the change with y sub 2 minus y sub 1 over x sub 2 minus x sub 1. And then we also took it a step further so you could graph using slope-intercept form. I will see you tomorrow. Have a good night.